Now, with example 4, we're going to do the same thing that we did in example 3. We're going to multiply radical expressions, but this time you might notice that we have two binomials that we're multiplying by. In the past, if we had like x plus 3 times x plus 2, well, all we'd have to do is multiply the very first term, the first binomial, times the entire second binomial. So I'd get x times x plus 2. And then do the same thing with the 3 and multiply it by the whole second binomial. So plus 3 times x plus 2. And of course, distribute everything out, combine like terms. That's what we would do with just normal binomials getting multiplied out. Same process. Distribute, distribute again, combine like terms. So find the area of the rectangle. Well, area, of course, is length times width. So the area is going to equal 5 roots of 2 minus root 3 times root 5 plus 4 roots of 3. So I'm going to take the first term of the first binomial, 5 roots of 2, and it's going to get multiplied by root 5 plus 4 roots of 3. So take the second part of the first binomial, negative root 3, and multiply it by the entire second binomial, root 5 plus 4 roots of 3. Distribute everything. 5 times 1 is 5. 2 times 5 is 10. 5 times 4 is 20. 2 times 3 is 6. Negative 1 times positive 1 is negative 1. Root 3 times root 5 is root 15. And negative 1 times 4 is minus 4. 3 times 3 is root 9. Ooh, I can take the square root of 9. The square root of 9 is 3 times negative 4. That's going to get me 12. 15 I can't split apart, so it's going to stay there. Root 6 I can't split apart, so it's going to stay there. 10 just breaks down into 2 and 5, so it can't do anything with that either. So I have 5 roots of 10 plus 20 roots of 6 minus root 15 minus 12. No like terms to combine there. Sometimes you will have like terms and you'll have to combine them all together. You just have to kind of watch out for it. But that's the area of that rectangle. I just multiplied the length and the width. The length and the width just happen to be very unfriendly numbers instead of like 8 and 6, right? It's the same process, it's just a little bit more complicated now. But something we can totally do. If you want a shortcut to everything we just talked about there, um, page 637 has a nice little concept summary box that you can see here. It's just a good little quick reference to everything. So that's the end of the section.